talk about is network log analytics. And this is actually work with several of my colleagues. Can you please move to the next slide, please? Or should I do? Okay. So here is how I'm going to structure the talk. The first 3-4 points are actually very introductory because I think these are all sort of reasonably well known to folks in Cisco. I'm just describing this so that people get a flavor of some of the work we do. And I'm going to talk about some of the solution techniques. That's where I think we are going to look for your expertise, suggestions, and how we can improve and all that. And I'm going to share some results and also possible other areas that that we want to explore. Yeah, next slide. So one of the challenges in network management is for a network manager is network visibility. Network visibility means they want to understand what is happening. Yeah, can you please click on all the bullets if you don't? Yeah, thank you. Oh, sorry. Okay. This is one of the pretty slides from. We have an event called Cisco Live, and this is one of the pretty slides. So we have a lot of measurements from a network, like a SNMP, Simple Network Management Protocol. Syslog, what I'm going to talk about. CLI is something called Command Line Interface, and then NetFlow is a sort of a streaming protocol where data is exported. And I haven't listed. It's not an exhaustive list. It's only a subset, and each of them have their own challenges. Some of it is very device specific. Some of the data is very slow, command line interface, and they are often very hard to operationalize because there are several devices, and each let's say iOS XE CLI is different from XR to NX and all that. And then Syslog is unstructured data. So in a sense, what happens is with all the measurements, to get a composite view of the network is actually a very difficult problem. So, okay. And here are some of the, yeah, please go to the next slide. Please interrupt if there are questions. And as I said, these are all very introductory from introductory slides just to set the context. And all that. For some of you may know, for some of it, it might be new. There is actually software, by the way, there is a lot of work that happens in network telemetry as such. And it's an overused term. And there is software aspects and hardware aspects, like CPU, memory is collected from all devices. Link statistics like packets, bytes, CRC errors, buffer occupancy, and all that. And Syslog is the one that I'm going to talk about. I'm just listing out all of them in detail. Quality of service, and then there is also hardware statistics like NetFlow, which talks about the flow statistics for all the flows in the network. IPSLA, that is sort of measuring the latency between adjacent devices and all that. And packet drops and all. So there are several data sources. I'm just setting a context. Where are the data sources coming from? Next slide, please. So given this context, one thing is, the problem that I'm going to focus on, it's actually the entire network telemetry is a very big problem. I'm just going to focus on a smaller subset of Syslog, and I'm going to mention why I'm interested in this problem. One is, as a network manager, you want to find out problems before they happen. After the fact, it's always, there is an outage and then customers are not happy and all that. So you want to take preemptive measures of corrective actions before they actually happen. And events don't happen just all of a sudden. They actually build up gradually over time. So if you see some early warning indicators, can you actually predict there is going to be a more severe event that is going to happen down the line? And then can you take some remedial actions and all that? And some of the examples that I mentioned is that, let's say when the CPU keeps on growing, let's say 70 to 80 to 90 and all that, eventually the router will exhaust and the router will crash and then reboot, which causes extensive disruption in the network. And similarly, let's say, for example, every network device has a fan to cool the system. If one of usually the fans are in dual redundancy mode, even if one of them were to fail, the device can get overheated. When the for an overheated device, the device will actually crash at some point and all that. So whenever we get an early warning of some of these notifications, can we infer the events that are going to happen down the line and then take corrective actions before catastrophic events happen in the network? So that is roughly the idea of syslog analysis. The last point, which is sort of covered in the thing, is that with all this is a classic sort of big data problem. We are in the our department focuses on data analytics. So there is a lot of data, syslog data generated from all the network devices, and often there are millions of logs generated, and often the most important logs might be 10 or something. So this is there is a very often used overused term called needles in a haystack, which you will see in many conferences and all that. This is actually one such problem. So, and these are all important needles because if you ignore them, and as I said, the consequences are very big. Please, next slide, please. So here is just a picture of syslogs are generated from all the routers, switches, and there are various other elements in the network, firewalls, intrusion protection systems, DNS servers, and all that. And all the data is eventually stored in syslog. And what I'm saying, the point is there are heterogeneous devices, and every device generates heterogeneous logs, and they are not of the same type. And so, next slide, please. Here is how a typical architectural, much simplified picture is that there are switches and routers, and I'll just illustrate only three. Is that they all export the logs to some central management system where all the logs are stored and they are all analyzed. And usually, most of the time, a lot of companies they use is from the data stored in the syslog collector. There is a downstream application called Splunk, which is actually a very profitable company right now. And then, they almost have a monopoly on log analysis and all that. And even in Cisco, we use them. And so that's how, and you can actually do a lot of various queries to analyze the logs and all that. Next slide, please. So I'm just going to again, I'm still in the introduction state, etc. I hope it is not too basic or something. Okay. So actually, syslog is actually a misnomer. It's an internet standard. RFC 5424 is the most up-to-date standard, and this actually evolved. I didn't know actually. This was very old stuff from the back 40 years old, from the Unix days of host logging. Syslog actually refers to the host the protocol, the wire protocol of what the events are. Okay, it's only the protocol that is the syslog, not the message itself. And most often people use UDP as a protocol because they want it to be lightweight, because the devices should not consume too much CPU memory to transmit the messages and all that. And of course, there are TCP and TLS options available, but that is not deployed in most of the networks. Okay. So just want to mention, so this is roughly what the syslog, and I also mentioned there are several papers on this topic in IEEE, ACM, and many such conferences on syslog analysis. And also, actually, there are many startups also. So that means that what it tells us, the problem is not fully solved. Syslog as such is there in the network industry for 20 plus years. If the problem is fully solved, you won't see the papers and conferences, and still there are startup companies coming up, and they are all there because they have solved the problem which others have not solved. Okay. Next slide, please. So I'm maybe I'll just mention through this quickly. So each syslog has a bunch of parameters. So something called a facility, severity, host name, the device which generates a log, the timestamp when it was generated, and the message. I want to focus on 2 or 3 things. I have given an example here. I'll ignore all the timestamp, the RTP12 and all that. Those are all straightforward. The point that I want to mention is about the BGP underscore session 5 neighbor, adjacency change. That is what is called a syslog mnemonic. 5 is the severity of the log, and adjacency change is a brief indication of what happened, and the description is given in pure text. Neighbor, something 10 dot whatever, etc., has been removed, so that that neighbor has changed. So this is in detail, but in a sense, the mnemonic, the BGP, is the facility that generated the log. In a sense, gives a summary of what happened, and the detail is given in the message. So this is roughly the log, and every description can be free-flowing text and highly unstructured. Next slide, please. So here are some examples. I mean, I don't want to go through every one of them. For example, environmental ENVMon is the one that tells you that the device temperature is very high. When a device gets very hot, there is a log that is generated. And you can actually set the threshold when you want to see these alarms. You can set them to be conservative, saying that, hey, I want to know only the SEV 3 and up, or SEV 4 and up, and all that. It is, in a sense, it's the how much conservative or the network manager wants to be. And there are the lower level logs, the 5, 6, and all that are called info level logs and all that. So here are some of them. And like for example, in the CPU hog is an important log that network managers would be interested in paying attention to, and all that. And also the fan fail, in which case they may have to do something and then replace the fan and all that. Okay. Yeah. Next slide, please. So the severity is the one that I talked about. There are various levels. The SEV 1s and SEV 0s is SEV 0 means that you cannot even use the system. SEV 1, SEV 2s are very super important from a network management point of view. Usually the 6 and 5, 6, and 7 are all often almost information sort of messages. People disregard those messages. But as I mentioned in the initial introduction, usually what happens is the errors build up over time. But if people ignore the lower severity warnings at some point, eventually gradually they build up over time, and then which can lead to higher severity issues down the line. So while the SEV 5 issue might not be alarming at a given point, but it will be useful to track how many of them are happening and across the network where it is happening. Next slide, please. Okay, so up to this is only introduction to syslog. I mean, if this is all, I mean, should be very for the folks in Cisco or any other networking company, these are all should be well known. And I just wanted to set the context. And in my view, if there is one slide that we want to a summary of my talk, this is my talk. This slide, and that's it. So what we are doing is trying to predict anomalies from the in syslogs, and there are two types of anomalies also overused term, and we need to be careful. One is what I actually, this is my own 2 cents, and I'm interested in hearing your feedback as well. There are events that happen rarely, and they are sort of intermittent. Once in a while they happen, and there is no regular pattern. And so sometimes I want to know what is happening in those situations also. But once in a while, so that I put it in a different bucket of rare messages, and I want to identify those logs as well. The second thing is what I call unusual clustering of messages. So by that I'm saying there are two types of clusters in a single event issue. Like for example, there is an event 1. I'm just talking in abstract. Let's say that typically occurs 100. The number of times it occurs is 100 typically, and suppose I observe 200. Should I be worried about it? Then I need to know why. Usually it occurs only 100 times, and now today I see in this network this event has occurred 200 times, and right now and there can also be multiple events also, event 1, event 2, event 3, in which case why is there a cluster of happening events that are happening? That's why I used unusual cluster also. So then I want to understand what is happening, evolving in the network as well. So there are two types of events, as I said. One is the rare events which can occur occasionally, and then this sort of what I call, to put it in statistical language, the events which are mean plus 3 sigma out sort of events. Okay. So the technique, at least we have proposed, I have to the preface I would like to say is whatever we have done, at least I have done, because all the limitations are only mine, or back of the envelope calculations, not very sophisticated. Okay, so what I call the detection of the rare messages is using a technique called statistical template extraction, and that uses bag of words, word embeddings, and all. These are all well-known techniques in the NLP world. So I will describe that in some detail in the next few slides. So that's for the first part. The second part is what is the clustering of messages. Do I see abnormal number of messages that I don't usually see? So we did something. This is maybe this is slightly not what I have seen in literature. Maybe a little bit more than I have seen in other papers as well. So we constructed something. What is the baseline? Baseline, I'm saying, what do I see over time for 30 days, or what a network manager would want to do? What do I see over 30 days? What are the distributional properties that I see? How many accounts that I'm seeing? And what is invariance to that? So, and that's what we have done. And we have used a very well-known technique, principal component analysis, to address that. So, and those are all, and of course, whatever we have done can be improved. There can be more sophisticated techniques that can be brought to bear to give better precision and all that. As I mentioned, our approach was to, in an industry setting, to come up with some quick results and all that. Shall I? Any questions till now? Or?
Yeah, Mouli? Uh, Mouli, can you hear me?
Yes.
So Mouli, are you doing a network-wide log analysis, or are you looking at a specific device?
Network wide, yeah.
Okay.
Yeah, network wide. Yeah. Let's go to the next slide. So here I have an example. For example, what is statistical template, syslog template extraction? Let's say for a given log. So I have, let's say I have collected the log from the entire network, let's say. They'll have the mnemonic, security, SSHD, whatever it is. And then the description will be on the right-hand side beyond the quotes, right, after the comma. So I will, if there is a way I can summarize the description as for the given mnemonic, client V1, the IP address is the variable here, and then the constant part is closest socket connection, sort of a very simple example. So with this, what happens is, I mean, I'll describe in a second. Let's go to the next slide, please. This is a more complex mnemonic. So BGP adjacency change. So that's the mnemonic. And then there is a neighbor, and then there is an IP address. There are a bunch of IP addresses. So I have a V1, which is a variable, and then down is a constant. And the notification sent, sorry, I am not able to see this. Okay. So the notification sent, hold time expired, etc. So you can see the AS number is a constant, whereas the VRF is a variable. So that those are also captured. So we can go to the next slide. Yeah. I'll pause here for a second. So with that sort of technique, and you'll be wondering why I am doing what I'm doing. With this sort of technique of the statistical template extraction, we collected something log of about some 10 million or 20 million from, let's say, Comcast, AT&T, or Goldman Sachs, or some of these networks. We analyzed the logs, and then we were able to extract the data reduction was about 750 or something. I mean, orders of magnitude reduction. So in a sense, that sort of helps the administrator to focus on, I mean, it's easier to focus on some things in the hundreds than in millions and all that, because they'll be purely overwhelmed. Can you do the full animation, please, if you don't mind? Yeah. Sorry. So what we want to, so if you follow the left-hand paths, like let's say I have all the 10 million or 20 million logs from Comcast, or for any of the network, I'm going to do the historical analysis, like what I said I'm going to talk about in the next slide. At least I just give a overview of how we do that. So we do all the analysis, and then we extract the statistical template, the constant and the variable part and all that. And then we calculate a hash function of the constant parts of a log, excluding the variable part, and then we store that hash. And then that is going to be like for a mnemonic to hash function, there'll be a table. For this mnemonic, this is the hash, that sort of thing. So I will do that offline analysis. That will be done once. So on a monthly basis or every 2 weeks, I'll collect all the logs from my entire network, calculate all the hash functions and store it. And then once I have that, the second part, the log stream, is the real-time analysis. What I'm going to do is that when a new log comes, I'm going to look at that new log and that mnemonic, if you will, and then see, I'm going to first compare the new mnemonic. Have I seen this before? If I have seen this before, I have to determine what pattern it matches, and then extract the template, like the same algorithm that I mentioned before, and then calculate the hash for the constant part, right? And then see if that hash already exists there in my dictionary. If it is not there, this is what I'm going to say. This is going to be my new log. So this is roughly what I'm doing. And you will be wondering, why is a network manager interested in this or something? So typically, as a network manager, what they will be doing is they'll be collecting logs, and once in a while they see something, that they haven't seen the last 2 months or something, and they'll be wondering what happened. Why am I seeing this log that I haven't encountered in the last month or so? Is it because of some device which is getting getting to a bad state, or is there somebody has configured something new on a device and that is acting in a funny way and all that? So when you see, this is almost like me driving my car, and I see one of the lights that comes up suddenly. At least I get worried. Hey, why is this yellow light coming? Maybe I need to take it to the mechanic. The same sort of feeling. So this is what it helps. I'll pause here if there are any questions.
Mouli, just one additional input. What would be interesting to do is when there's a failure on a particular device in the network, would it be possible to trace the sequence of events that has happened in the network and which has led to this particular failure, right? I mean, I was just wondering whether you're planning to do something like that.
So there is something what we call Syslog signature-based analysis that is currently underway right now. Yeah.
Okay.
I'll explain that later. So yeah, let's go to the next slide. So in some detail, etc. So to actually do that, I'm just describing the mechanics of how to do that. So first thing, what we do is, let's say when we have the repository of 10 million or 20 million messages, I have to group the messages that are similar. One assumption is that if the sentence length of the description is equal, I am also this is an implicit assumption. The assumption that they are also the error messages are also similar within the same mnemonic, of course. If the sentence has 26 characters, and even though there can be differences and all that, and then we filter out using the tokenizing algorithm using Jacquard index. Okay, and then we resequence them and all that. Okay. And then we form that document term matrix, which is probably well known to a lot of people. And then we look at the one-hot encoding type of technique for S1, S2, S3 or the logs, and T1, T2 or the tokens, if you will. And then see and then if I look at the transpose of that matrix, we can actually filter out what are the columns that have one values. Those are all the ones that are constant, and the rest of the ones are the variable ones. So as I mentioned, this is not very. This is at least our approach to do that. And of course, if there are other ideas, definitely look forward to hearing. So next slide, please. So as I said, till now what I have completed right now is what I have done is how do we find out the log messages that are rarely seen once in an intermittent basis. But as I mentioned, there are two types of anomalies. By the way, the anomaly literature is full of statistics. A lot of statisticians are working on it. And there are a lot of papers on ML, isolation forest, this, that, KNN algorithm, and all that. And I am looking at it more as an engineer looking at how I can solve a domain-specific problem, and then what is the right technique to apply, as opposed to me knowing some more sophisticated algorithm or something. Okay, that's I mean, my approach to this is a little different, but as that the literature is replete with papers on this topic, anomaly detection. And actually, there is also a book from somebody from IBM Research also on this topic, anomaly detection, and all that. So, which I have only browsed through, not fully. Here is. The anomaly just cannot be purely based on counts. If I see something, as I mentioned, the example I said, typically I see 100, I see 200, should I be worried? Yeah, that is one approach to do anomalies and all that. But in the world of Syslog, if I have a SEV1 or a SEV0 alarm, in my view, that's actually much more important than a SEV4 alarm. Okay. So the severity of the log is also important, and if the log, if the same log appears on multiple hosts, that means that the problem, it's in a sense like it's not the problem is not isolated to one host, or at least there is a subset of hosts which seem to have the problem. And I would also relax that word same by that I'm saying you may have one issue on another node, but another related issue on another node. So in that sense, I didn't want to use the words same, similar here also. But if we can look at similar issues that are happening in a subset of the nodes, then that's even more important. Okay? And then the network manager has to pay attention. And then another important consideration is if a log appears frequently in all devices, etc., most of the time people ignore, and they don't, they are not worried that much. So okay, so our proposal is to look at a scoring scheme for weighting these events. We have, let's say, the mnemonics counts. For each mnemonic, how many counts are there? But on top of that, to incorporate all these considerations, so we thought we will devise a scoring scheme. And the scoring scheme, the way I have laid it out, you can see that it is not. It is actually based on extension of TF-IDF, and it's a variant. And then and you can actually adjust the weights in such a way that the events that I have mentioned, the property actually bubble up instead of, and then I can suppress some of the things that are not that important. That's the crux of the idea. So once I have that sort of scoring scheme, yeah, next slide, please. Okay. So we have. So what I have is. So as just trying to transition from the previous slide to here, I'm just thinking. So we have the list of mnemonics that are observed in the network, and I observe the network for, let's say, 30 days or 60 days or 100 days or something. And then we construct what is normal behavior. I said, so let's consider time window of m days and etc. And this is all, I have set this up notation. So for those of you, I didn't want to just wave my hands completely and just say we are using principal component analysis to do that. For the measurements that are collected, the matrix is basically m is the number of days, n is the number of features, mnemonics. In a given network, you can have, let's say, there are several mnemonics that you can observe. Typically, what we have observed in our networks is about 200 to 300 mnemonics that are most often occurring. So in a sense, that will be, let's say, if there are 100 days and then 200 mnemonics. So that will be the sort of size of the matrix. And then we use the principal component analysis. The notation should all be I'm not going to the detail, etc. This should be, for you folks, this should be very straightforward. Next slide, please. If there are questions, please tell me. So, and the idea is that once I use the principal component analysis, I can capture most of the variance with a subset of the n features by, let's say, the first k principal components. And then I can have a normal subspace and an abnormal subspace, partition that. And then for a new vector that is happening, for the, let's say, for a particular day, let's say I have a data of, let's say, the past 100 days, and then I observe the data for the 101st day. What is anomaly on the 101st day is just a projection of that new vector onto the respective subspaces in the normal subspace or the abnormal subspace. And mathematically, there's also, these are all standard things that textbook, what shall I say, principal component analysis calculations. We can go to the next slide. So, how do we detect the anomalies? Let's say how do we separate out the two? So there is a pretty reasonably old paper by Jackson and Mudolkar, where they talk about the principal component analysis based on this Q statistic, and the Q alpha is the threshold, and so this is the squared error of the residual function for a particular confidence level, and then there's and they have shown that actually forms follows a Gaussian distribution, but the parameters of the Gaussian distribution, the mean and variance, are rather complex, and the folks have actually looked at some heuristic way of solving that, and you can technically we can use such heuristic approaches to determine the quantile value of the normal distribution to fix your anomalies. So there are some, as I said, assumptions are also there in terms of when is it a Gaussian distribution and all that, based on some very old papers and all that sort of stuff. Let's go to the next slide. Yeah. Oh, okay. We are almost there. So we have concluded our the anomaly detection procedure on two things. One is detection of the rare events, and secondly, the anomalies based on count-based, frequency-based things. And we have deployed that internally, and we are actually in the process of evaluation right now. And as I mentioned, we have used simple back-of-the-envelope sort of calculations for the analysis. Definitely, there is a greater need for mathematically more sophisticated techniques. I have some ideas as well, and what can be done. In a industrial context, we often look for, there is often a need to do immediate prototypes, pilots, and all that. So we resort to techniques that we can do very quickly. This is the point that I think Kannan was mentioning some time back. So the reason I mentioned, so the first three things are with respect to what we have done with respect to anomaly detection. Are there other problems beyond this with respect to Syslog? Obviously, there are a lot more that we haven't solved. One is, let's say there is a pattern of events that you see, or is that a signature of those events reflective of failure in the network? Obviously, there are many networks, from AT&T, Comcast, Goldman Sachs, various other companies. They have been running networks for a long time. They have data, and we can actually look at before a failure happens, what are the preceding logs and all that. So in a sense, if you are able to see these sort of events, you can also reasonably conclude that can be a failure. So there are some efforts um, underway right now. The simpler ones that I mentioned are the ones, let's say, for example, the temperature heating, fan failure to temperature heating to router failure. So that's the most often thing. But there are also other things with respect, and also some unusual patterns as well that we haven't detected before. So, and also one of the things that was also insight that was mentioned was one reason for possible failures in the networks can be caused by uh, configuration changes in the network by technicians and inadvertent mistakes in the configuration can have ripple effects in the network and cause possible failures and all. So there are several such hypotheses on this topic. So the signature of syslog events is one area that's not fully. I mean, it is still an open topic. The other topic is the identification of the root cause of failures. What I have said is till now is what are the events, can I identify those particular events and all that. But behind that event, there is something else that is happening within the router or the network that is actually the root cause of the failure. Is it a configuration that caused the issue, or some other protocol interaction that is causing the issue? And as I said, this is an area actually there are some startups and started ups. By that I'm saying MoveSoft and all these companies are actually actively working on this topic, and they are actually working with various vendors to license their software in this arena for the root cause analysis topic. This is an area where I think there is a lot of opportunity for people to contribute, both in terms of mathematical analysis and also data analysis. That's all I have. Ready to take questions if there are any.
Hi, only one question I have. It's a very nice presentation. Thank you for that. The question I have is, did you find any cyclic nature of the syslogs, in the sense that certain syslogs appear more frequently during a certain period of time in a day, certain time of the day, and also certain day in the week? And if that is the case, how do you set a baseline given that it is a cyclic in nature?
So
Mouli, if you understood the question, could you repeat it? I couldn't hear the question properly.
I think if I can repeat the question, what I understood, are there cyclic or diurnal patterns with respect to syslogs or something?
Yes. Can you hear me okay now?
Your audio line is.
So perhaps you can type out your question, sir. So there's a chat window. Perhaps you can type out the question there and it can be read here.
No, I think Mouli has already identified the question, and maybe he can answer the question.
Yeah, of course. Yes, definitely. There are some clear patterns by time of day patterns in logs. One of the things that happens is typically in networks, they configure the network at quote unquote, if they want to make changes to the network, they do that at midnight, 11:30 to 1 a.m. or sort of thing. And then when there are changes in the network that happen, like for example, then they have to do several other things. And you can systematically see there are these sort of syslogs related to authentication and all that sort of stuff. And you can see that high volume. And secondly, another thing that happens is that, so we can actually see a pattern in terms of, and VM moving from, right now, we don't have this old-fashioned notion of Linux boxes, etc. Right now, you have an application running as a VM in box 1, and then that moves to another Linux at another time when during lightly loaded situation. And these are all almost there is a time of day pattern to that. And what the I mean, this is the network manager's view on that is, when they know these are expected events, they are not expected that they know that this is going to happen, they are actually a little less concerned. Yes, I know I'm doing this, and as a consequence, I'm expecting to see this. I'm not worried, and they often ignore that, and so actually we even filter out those sort of messages, etc. And what they are more interested is, are there some things that unexpected events that they didn't expect.
Hi, can you hear me now?
Yes, I can hear you now.
So my question was, how do you set a baseline in case when the events are cyclic in nature, right? So you like we're typically used to seeing a baseline as a horizontal line. I mean, obviously events happening around the horizontal line, and a threshold also has a horizontal line, which is above and below the baseline. So in case of a cyclic syslog, how do you set a baseline and how do you set the thresholds?
Okay, I don't. Okay, so there is I don't want. So what I don't want to say as a cyclic and sinusoidal pattern, that sort of thing. Actually, so what we need to look at is the logs as you can think of from a pure probability. If you forget about logs and all that, if you think of the mnemonics as events, so you will have, let's say, in a sense, you are trying to form a histogram, if you will, based on patterns and all that. On a particular day, it's a two-dimensional histogram that's what you're trying to do, basically, based on all the days and all that. So that's the way I conceptualize what we are doing. So the thing you are thinking of the standard, let's say, mean plus 3 sigma sort of control chart sort of model. I'm not visualizing it like that. Do you? I hope I answered your question.
Yes. Thank you. Yeah.
Any other questions?
I have a question, Mouli. Rajesh here. Hello.
Yeah. Go ahead, please.
So the question is about use of PCA. So if you're looking for, let's say, some anomalies, and those anomalies are hidden in some rarely occurring features.
Yes.
PCA may not capture those features.
Correct.
And when you do PCA, you lose this information. So correct. Is there some thought on how to maybe capture those features and reweigh them so that they still emerge in your reduced size description of the data?
Correct. You're 100% right. PCA is technically only for the linear regression model, and if there are some non-linear effects and all that, how do we capture that? My honest answer, I don't know. My honest answer, I don't know. But we are trying. There is this technique called isolation forest. Not sure. It's sort of a variant of what is it? Random forest model for picking anomalies. But supposedly it performs a little better. But I'm definitely that is an area that we haven't looked at. And if there are suggestions, I'll be very interested.
Thank you.
Mouli, this is Preetham here. I had one question about how whether the log has been also combined with the other two components, that is the configuration as well as the network flow. So
Yeah.
the net flow and or the open flow tables.
Correct. Exactly. Excellent question, Preetham. Yes, that in my view, okay, there is a limit up to which you can push or extract information out of syslogs alone. Syslog is only a reactive tool in the sense that something is generated only after the event has happened. Something happened and you generate a notification. And it's also very coarse grained, if you will. So we need to actually factor in some other telemetry data, like for example, net flow or SNMP or some other data, and then see how we can actually predict failures and all that. And we haven't, that problem in my view has not been solved. And I haven't seen any startups also, they haven't solved that company. Maybe Rajesh might know. There is one guy, Rajiv Gupta. He has a very famous. He has a startup company. I don't think anybody has solved this problem. I mean, it's an important problem. I haven't seen others. They haven't done that yet. Very good question. And my honest answer, even in Cisco, we haven't solved the problem. We understand the need that we need to do that. But the honest answer is to the other question that Rajesh also asked, we don't know how to do
that. I have a question. Can I ask?
Yeah, go ahead.
Okay. I'm Mouli. This is Himanshu here. Just a question about, by the way, very good talk. A very nice set of problems here. So one question I want to ask is about the framework itself. Are there some distributed framework setup where the data is not collected at a single place and somehow we want to reduce the data size at the source itself?
Excellent question, Himanshu. Yes, there is superb actually. There is some work underway, but didn't take off. And there is a new effort that is actually happening called something called federated ML or something. So in a sense, can you push some of the algorithms that whatever you're doing at the centralized cloud, not all of them, push some of the basic processing to closer to where the data is generated, and then only filter out. And then there is also a trick. If you filter out too much, then at a network level, the question that Kannan was asking, you might actually lose out on the network level picture. How much should be federated and all? That's a question that people are investigating. I'm talking only from the syslog point of view. And that problem has not been solved. If I can say this, if you solve the problem, I'm sure there is a big startup there, I can tell you.
Okay, thanks. Maybe I'll follow up separately via email. Very interesting.
Definitely. There's a very good problem. I don't think the problem has been solved. Any other questions?
Can I ask another question, Preetham here?
Yeah.
So many of these logs, again, they are meant for kind of post-facto analysis, and there is some kind of like streaming ETL mechanism sitting at the log central log location,
Correct.
which dumps it in a database, right? So some form of database where they can be queried by analysts and all.
So that's what Splunk is right now. Yeah, Splunk is a company which actually spun out of Berkeley, and that's what they do. Yeah.
Right. So, is there any effort to run some agents at the device itself? To one again, coming back to Himanshu's question of reducing the volume of data.
Sure.
And
Okay, so I have to, okay. Very excellent. There are also business models. Splunk is actually a pretty big company. I don't know, $3 billion or something. So obviously, from their business interest point of view, it is better to collect all the logs in the cloud and perform the analysis. And the way they do the license is, if you have 10 TB of data, I don't know, let's make it $1 for every gig or something. So I don't know what is the pricing and all that. So it is to their advantage to have the more you store, the more money you pay. So they wouldn't want that. Actually, on the distributed part, actually, I had written a couple of papers on distributed analytics with my colleague Alex Clem, and we met with the CTO of Splunk, and she was saying, "Oh my God," and went to a very interesting conversation. And she was saying, "Oh, hope you guys don't put us out of business or something," because if you do more processing at the edge, you don't have to store the data in the cloud. Obviously there is a trade-off, but then the more you process at the edge, you also lose the network effect itself. So it has to be done carefully, if I may. Right. So you want to get the network level picture itself. Otherwise, the SDN control, the Splunk, then the question is, there was also a question, are you doing device level statistics or the network level statistics? Because if there is a fault in one device, that device is probably not going to be at fault alone. There is going to be some, you guys are also doing all the COVID analysis and everything. There is going to be some sort of distribute, the other neighbor devices may also get induced with some faults and all that stuff, right? So you will lose that if you do more of the analysis at the edge. Not much, the summary is that not much has been done in that area, and it's an excellent area to from a pure research point of view, it's an excellent area to work. At least that's my 2 cents. And I think that will be a very worthy, what shall I say, objective for a place like IISc to pursue, because that's it's a forward-looking thing. Might take 2 or 3 years or something for the fruition and all that.
So one related question, again, sorry for hogging the time. So is from historical perspective, we see that it's the Syslog template and format is very verbose and not very efficient in terms of the numerical information transmitted. Yeah. So is it purely for historical reasons, or there is a value in sending all the complete text over the wire instead of sending it in a structured data? So like the Syslog can be looked at as a NoSQL, unstructured data.
So for some extent, some of the data is actually is very important, because if you know there is a fault, you want to know when it occurred. So you need the timestamp, which device it happened, and all that. Some of this is actually absolute must. So like where it happened, which device, and what is mnemonic and all that stuff, and description, everything for to do the troubleshooting. And usually what they do is, once they know which device, etc., they actually telnet to the device, and then actually look at the router configurations and all that, and then see what was the reason why there was an error and all that. So there is actually a lot more troubleshooting. The Syslog is only an indicator. This is like you going to your doctor and having a temperature. Obviously they are going to do more tests and all that. So then they log into the device and then look at why, what's happening, which process is actually taking more CPU and all that stuff. So some of that is absolute must. How much data that needs to be there. It is actually, by the way, syslog from routers and switches is actually not that much. But if you look at some of the MapReduce stuff like Hadoop and all that, the logs are actually, my God, awful. I mean, I should say, I mean, there is nothing you can do. I mean, actually, they will have, there are a lot of jobs available for NLP people. That's all I would say. And we are also looking at SSL load balancers and all that. SSL is the secure socket layer for you to connect to within the network and all that. The logs are, I mean, it's almost like gibberish, to be honest with you. Sorry, I mean, it's 4 or 5 lines, but to parse that itself is and to extract something out of each line is very difficult. And networking has done a lot in the sense of coming up with the internet standards and all that, and to some extent it's reasonably structured. That's all I would say. I mean, others haven't really kept pace with that, I would say. Any other questions?
Okay. If there are no more questions, then let's thank Mouli sir for a great talk. Thank you, sir.
Thank you. Thank you very much. Thank you for the opportunity. Appreciate it.
Yeah. So next week we have another speaker. Again, he's doing his PhD outside. So we'll send out an announcement about that soon. Thank you everyone for participating.
Thank you.